Okay, so we left off on SOHCAHTOA, right? So we're gonna make this really quick. So you guys are a real good bunch here, should be very quick. So SOHCAHTOA, remember, quick reminder, the first letter of the name of each part of SOHCAHTOA is just telling us which trig function is it, sine, cosine, or tangent. The next two are telling us what divided by what is equal to that ratio, right? So for example, if I have a right triangle and this is the angle, we'll call it theta, that I'm gonna calculate my trig functions based on that angle from its perspective, then that would be the opposite side, the adjacent side, and the hypotenuse, right? The hypotenuse is always gonna be the one opposite the right angle, and you all know. So then, for example, in this triangle right here, from the perspective of angle x, what's sine gonna be? What's the ratio gonna be? So it's going to be the sine is always going to be opposite leg divided by hypotenuse, right? So what's the length of the opposite leg? 6, and the hypotenuse? 10. Very good. So we end up with 3/5 if we reduce that, right? Okay. So what about a situation like this one now? So this is, we didn't look at the tree one yesterday, did we? No. Okay. So here's where trig comes in handy. When you're trying to do something like we know we can come up with a situation that's modeled by a right triangle, and I know an angle and a side length, but I want to find another missing side length. That's where trig ratios become very important. So what about this one? We've got somebody standing 10 feet from a tree. They can't accurately calculate the angle of elevation. And by the way, when we talk about an angle of elevation in math, it's always going to be the angle made by a horizontal, like in this case, the horizontal ground and the line of sight. That's what always means an angle between another ray and a horizontal every time. Okay. So here's our angle of elevation. It's just the angle that you're looking up at the top of the tree from, right? She doesn't know exactly what it is, but she knows that it's going to be between 55 and 75 degrees. Okay. So she wants to know then, or we're trying to decide which of these possible heights are reasonable based on those angles and which ones are not, right? So we've got to figure out for an angle of 55 degrees, how high does that predict the tree would be? And for an angle of 75 degrees, how high does that predict the tree would be, right? So we know here's our right triangle we can build. The height of the tree is what's unknown, so let's call that x, or h, or whatever you want to call it. We'll call it x. That's what we're trying to find, and the distance to the base of the tree is 10. So then that's the right triangle we're going to use. Is from our angle's perspective, it's going to be the one where we're interested in relating the angle to the adjacent leg length and opposite leg length. And we know that those are, for us, that's 10 and x, right? So then we're just going to come up, we want to pick the trig ratio that's going to use from this angle's perspective that's going to involve opposite and adjacent. Well, which one is that out of SOHCAHTOA? Sine, cosine, or tangent? It's tangent, isn't it, right? TOA. Okay, so we want tangent. Thank you. Thank you. Okay.
Bye, Lily.
Not here. I'll be back to you.
Who?
Okay. So tangent of theta would be opposite over adjacent. So for us, that's x over 10, right? So if we get the equation tangent of theta equals x over 10, how would I solve for x? How do I undo dividing by 10? Multiply by 10. Right? So if I multiply each side by 10, I get x equals 10 tangent theta, right? And then we just need to figure out what that's going to give me when I plug in 55 degrees or 75 degrees. Now, those are calculator numbers. That's not something you're going to know ever. It's something you're going to plug into a calculator. So here is what the SBAC calculator looks like. Where is that? There it is. No, it's the same one. It's the one I built into all the Moodle stuff, right? So it's the one you're used to. Okay, so it's the Desmos calculator. All right, so all we got to do then is we wanted to calculate the tangent of 55 degrees, right? or 10 times the tangent of 55 degrees. So we do 10 times, now how do you get tangent? You got two options. You can just type in tangent and then open up a set of parentheses. That's fine. Or alternately, phone should be away please. Alternately, you could go down and you could open up the keyboard, go to functions, and there it is, tangent. Okay, we're going to plug in 55 and it gives us the answer. Okay, now the SBAC version of this always defaults to degrees, which is what you're going to want it on for the test. The other version always defaults to radians, the regular version, which is kind of like a pre-calc and a calculus thing that we'd use a lot of, right? But you might want to just double check that if you ever needed to change it, and you won't need to. You won't need to. Do you guys even know what a radian is at this point? You've never talked about them, right? So it's not even anything you'd ever need until you get to trigonometry next year, right? Or the year after. But if you ever want to change that, any of the settings you'll change on Desmos, you just go up to the wrench and you can change anything you need to, right? So we could click between radians and degrees, but we want degrees. So that answer, it rounds to 14.3. If I plug in 10 times the tangent of 75, it rounds to 37.3. And we just need to find all of the answers then that are within that range, right? So we've got 14.7 is between 14.3 and 37.3. That would work, but the rest of these are all outside of our range, so they wouldn't work, okay? So it seems like a really big problem, but that's really all it's working with the SOHCAHTOA stuff, okay? How about something like this then? Which of these expressions, let's just do a couple of them. Let's look at a couple of these. Determine whether each expression can be used to find the length of side RS. Let's just call it X, so it's easier to represent. So let's try this first one, for example. What if we want to try 35 times the sine of R? Well, what is the sine of R? Of angle R. There's angle R right there, right? So opposite over hypotenuse, good, that's SOHCAHTOA. So SOH, sine is opposite over hypotenuse. What's the length of the opposite side? 21. What's the length of the hypotenuse? 35. Okay, so if I multiply that by 35, does that give me what I'm looking for? Does that give me X? No, it doesn't, does it? 35 times sine R is equal to 21. It's not equal to X, right? So that one is a false. Doesn't work. Okay, what about the next one? 21 sine of T. Okay, so here's angle T. Tangent T we want, right? So what's the tangent of angle T? Here's angle T. Tangent is what ratio? What over what? Adjacent. Opposite over adjacent. TOA, T-O-A. Tangent is opposite over adjacent. Okay. So opposite for angle T is X. Adjacent. Okay, so if we multiply both sides by 21, what happens? I do get X, right? So X is equal to 21 tangent T. So that one is a yes. Now that expression would allow us to find the value of X, find the length, right? Okay, make sense?
Yes.
Okay. Okay, what about these? Well, the big thing here is just that we want to remind ourselves about some geometry stuff, right? So we know that if triangle DEF is similar to triangle RST, then we know that D and R go together, right? So angle D and angle R are congruent. Their measures are the same. Similar triangles, all the angles are the same. They always have to add up to 180 for a triangle, don't they? So the angles don't change, but the lengths of the sides do, right? Similar means same shape but different size, okay? So then we know that angle E is the one that's congruent to angle S because they have to go in the same order. So we get this, right? And then, of course, angle F and angle T, those are the right angles, so those are obviously the same, right? Okay, so then decide whether each statement is true. Mark true or false for each statement. cosine of angle D is greater than cosine of angle S. So all we have to do then is just look at what each of those ratios is. So let's look at cosine of angle D. Cosine of angle D is going to be what? Angle D. Now, we don't have a triangle that has all three sides in it, do we? So how can we know? But I have two sides in this one. If I have two sides in a right triangle, I could always fill out the third one, couldn't I?
Yes.
By using Pythagorean theorem. Because leg squared plus leg squared equals hypotenuse squared, right? So 7 squared plus st squared, we call that distance st squared, right? Or st, has to equal 25 squared. Right? If I want to figure out what the length of that missing side is, then I could just subtract 7 squared away to that side. I could square root both sides. And if I do all the math, I get 24 for an answer. Right? So we could fill out this triangle. We now know all three sides. Even though angle D is in this triangle, it's the same as angle R, isn't it? Right? So when I want to calculate the cosine of angle D, it's the same thing as saying the cosine of angle R. Right? Well, what is the cosine of angle R? So here's angle R. Cosine is what over what? No. Adjacent. It's ca, right? C-A-H. So it's adjacent. So 7 divided by hypotenuse, which is 25. So we want to know, is that greater than cosine of S? What's the cosine of S? So from S's perspective, yeah, we're going to get 24 is the adjacent leg, 25 is the hypotenuse. So that didn't work at all, did it? Right? That's not true. It's false. See how that works? Okay? You get the idea? Okay, I'm going to skip forward though. Oh, one other one on this page. So let's take a quick look at this guy. So we've got this triangle. Let's just build a right triangle here. And we've got some angle that's 39 degrees. Okay? It says the cosine of 39 degrees is 0.7771. Okay, cosine is the ratio of adjacent over hypotenuse, right? So we know that this is the adjacent side. For this angle, that's adjacent and that's hypotenuse, right? Okay, how are we going to make a fraction out of that though? Well, one easy way to always make a fraction, it doesn't have to be a legal fraction. We could always write something like 0.07 or 0.771 is just itself divided by 1, right? So we could do that. We could say that from the perspective of this angle right here, adjacent over hypotenuse, which is what cosine gives us, must equal that number divided by 1, right? It works. Okay? We're not even going to worry about finding this other side, okay? Because look what the question asks us. It says, find the angle measure beta in degrees where the sine of beta equals the same ratio. Okay? So where would that angle beta, it's like just a Greek B, where would that other angle need to be so its sine ratio was the same thing? Right? Wouldn't it have to be where this becomes the, now instead of being the adjacent, it has to be, if we're doing this, right? That's going to have to become the opposite, right? And that stays the hypotenuse, if it's a sine ratio. So what would the angle have to be then? Which angle would we be talking about? If that needs to be the opposite, and that's going to be the hypotenuse, it's not that angle, it's that one, isn't it? Right? Okay, so that's going to be the angle we're interested in. But what would that angle have to be? 51. How'd you get that?
90 subtracts 89.
Okay, we know that the sum of all these in any triangle has to be what? 180, and that's 90, right? So if it's a right triangle, the other two acute angles always have to add up to the other 90, don't they? So that's going to end up being 51. Okay, you get the idea? Okay, and don't ignore their, that was a bunch of trig nonsense, we don't have to worry about, right? We're just looking at this in terms of a right triangle, okay? So 51 would be right, okay? Would be the answer with the 51 in. Okay, what about this one? Consider this right triangle.
Yes.
Find the measure of angle y to the nearest degree. So how would we do that? So one last trig thing and then we'll move on. So if this is angle y, which of the trig functions is going to be the one that we would want to use that would connect those sides that have lengths of 9 and 14? Sine, cosine, or tangent?
Opposite over.
No.
Adjacent over.
Opposite over hypotenuse. Good. So we've got opposite and hypotenuse. So that'd have to be a sine, wouldn't it? So we get sine of y is equal to the ratio of 9 over 14. Okay, so the question is just, how do we undo a sine function? Like if we wanted to undo a cube function, we would cube root it, right? If we wanted to undo a cube root, we would cube it, right? Does that make sense? So we always want to do the inverse to of whatever function we're working with to isolate the variable, right? So my example, you get this example, right? Like if we had x cubed equals 8, then we would just cube root both sides to isolate that x. And we get x equals the cube root of 8, which is 2, right? Okay. How do we do that for a sine function? How do we undo a sine? Do you remember? What is it again? Inverse sine. Yep. So we're going to do inverse sine. Okay, and that's going to cancel out the sine. And then we just end up with angle y equals whatever that gives us. The inverse sine of 9/14, and that's a calculator number again. So we'll just put that in our calculator and see what we get. Okay, so inverse sine of 9/14. So we got to go down to our functions, and there's inverse sine. And then just 9 divided by 14, and what do you know? What's it give us? Rounded to the nearest degree, what do we get? 40. There we go. Okay, so, oh my goodness, there we go. Okay. There it is, 40 degrees, right? Okay? All right, so now moving on. Next issue. Okay, so solving radical equations. This is a unit that we're still going to cover, but we can do the basics in just one day. It's pretty simple stuff. Okay? So if we ever have like radicals, so I've got a fifth root of something is equal to a fifth root of something. What can you tell me about the green something and the yellow something? If it's an equation so that both sides have to be equal. Gotta be the same, don't they? If I'm taking fifth root of this and the fifth root of that and they have to be equal, then the this and that have to be equal, don't they, right? So we could just say that we can set these equal. 8x plus 3 has to equal negative 8x plus 10. I would add 8x over here and get 16x, subtract 3 and get 7. So x would just be 7 over 16. No big deal. Okay. But what happens if I don't have something so easy? What happens if I've got just a radical on like one side? Okay, what do? How would I undo square rooting? What do I do? Square it. I'm going to square both sides. Okay. So if I square both sides here, the square is going to undo the square root, and I just end up with x plus 5 equals what's 5 squared? Okay, and I subtract 5 and I get x equals 20. Here's the deal though. Whenever you take both sides of an equation to a power to solve it, whenever you take both sides of an equation to a power, you always have to check your answers because that can introduce extraneous or false solutions. Right? So if I plug the 20 back in, what happens? If I plug 20 into my original equation, I get the square root of 20 plus 5 equals 5. True or false? True. So it works. It is a solution. Okay, what about this one? What am I going to do here? I'm just trying to solve for x, so I'm going to use the same kind of approach. I'm going to have to get rid of that radical, aren't I?
Square root.
But first I got to isolate the radical. I got to get it by itself first, and then I can get rid of the radical by squaring. If I just square this whole side, that's going to be a huge mess, isn't it? Right, I only want to square the square root to cancel it out. So we isolate the radical. So we subtract 5, and that gives us square root of 3x plus 9 equals -4. Okay, now what do I do? Square both sides. Okay, so at this point, I can square both sides. Actually, what I want to do, let me, and so what do we get there? Okay, so the squared cancels the square root. 3x plus 9 equals positive 16. Okay. So what are the two steps to get the x by itself? Subtract 9, divide by 3, so I'm going to get 16 minus 9 is 7 divided by 3. So far so good, but remember I always have to plug that back into the original equation before I square it. I could go back to this step right here. I just can't. After I square both sides, that's when things could change, right? So I can either go back to the very original one, or I could even just go back to here if I want, right? Because I haven't squared both sides yet to get rid of the radical. So if I plug it in, well, we'll go clear up here, just see what happens. So if I plug it in there, I'm going to get the square root of 3 times 7/3 plus 9, and then outside of the radical I've got a plus 5 equals 1. Does that work? Let's see, 3 times 7/3, just 7, right? So I end up with the square root of 16 plus 5 equals 1. Is that true?
No.
It is not true, is it? Not true. So that is not an answer. It's not. It's an invalid solution. It's a false solution. I would claim that there was a step up here where we should have seen that coming. I'll tell you which step it is. It's that one right there.
The negative.
The negative. Yeah, look at that. When I isolate the radical, if I have a square root of some stuff is equal to a negative, is that possible?
No.
No. The smallest we could get is the square root of 0, which is 0. The square root of any positive number is going to give us back something positive, isn't it? Right? So right away we know right here that's impossible. So there's no way. We know we're getting no solution. Okay? Skip that guy. How about this one? What would I do there? No, hold it, but I got that darn square root in there. First thing I got to do is isolate the radical. Done. Right? And then how do I get rid of the radical once it's by itself? Square both sides. Okay. So if we square both sides, aren't I just going to get everything inside equals x squared? Everybody agree if I square both sides? So now what? We can solve that. Combine like terms. Which side should I push the x squareds to? The right, how about? So I get a positive number. So 48 equals 3x squared. Now what? Divide by 3, and I'll flip-flop these so the x squared's on the left. This gives me 16. So what do I get for my answers?
Plus or minus.
Plus or minus 4. Good. So let's try those and see what happens. Right, so if we try the plus 4, what do we get here then? That's going to give me the square root of -2 times 4 squared is -32 plus 48,
It's 16.
16. Is that equal to 4? It is. Yeah, it is. So that one is good. So x equals 4 works. Let's try the other one. So now if we try x equals -4, if I plug that in, I'm going to get the same thing over here, aren't I? Because I'm going to -4 squared is the same thing as +4 squared, 16. So I get -32 plus 48. That's the square root of 16. Is that equal to -4? No. Square root of 16 equals what?
4.
+4. That's not true, right? And so we know that this one is a false solution. We only get to keep one of them. Okay? Make sense? Okay?
Fake news.
Right? Okay, so last one. I want to just kind of, we'll just start this one, we'll finish it on Monday. So this is a performance test. We only got a couple minutes, but let's at least familiarize ourselves with it. Your friend Abby is making a movie. She's filming a fancy dinner scene, and she has 2 types of candles on the table. She wants to determine how long the candles will last. She takes a picture, lights the candles, and then lets them burn for 1 hour. She then takes a second picture. You can assume that each candle burns at its own constant rate. Okay, so what we're looking for here, then the question that's being asked is, if they're lit at the same time, what will be the height in centimeters of each candle after 3 hours of burning? Okay? So there's a couple ways we could do this. We could do this kind of the algebra way, right? Does this make sense that if we were going to do this the algebra way, we could just say something like for candle A, if we're going to say that, how about if we say H equals height and T equals time in hours, then for candle A, what's H going to equal? What's going to be the equation we'd come up with for candle A? What's the rate at which it's burning? In 1 hour it burned how much?
4 centimeters.
4 centimeters. So it's losing height at a rate of 4 centimeters per hour.
So 4x.
So 4t in this case, right? So that's how fast it's losing height. What's its starting height? 20. So I'd get what? 20 minus 4t. Very good, right? My starting value plus my rate times time. My rate is -4, isn't it? Because it's decreasing by 4 centimeters every hour. So there's h of t. For candle B, we get the same thing. And now our initial value, our starting value is 10. And our rate is -1, isn't it? Because it only went down by 1 centimeter in that hour, right? So if we want to know what the heights are at time equals 3, well then we could just plug those in. For candle A, if I plug 3 in for T, I get 20 minus 4 times 3, well that's just 8, right? And for candle B, I'd get, if I plug 3 in, 10 minus 3, which is 7. Okay, so there's one way to do it, and that's fine. You can also do it this way, right? We could just fill out a table if we wanted to. Okay? In our table, right, this just gives me, like if I keep track of time in one column and the height of candle A and the height of candle B, you know, they're all going to drop each hour, but I can see that after 3 hours, there are my answers. That works, doesn't it? Right? Okay, so for the first part of this, I want you to notice that all they care about is, did you get right answers? Okay? It doesn't matter in this case if you have to go back, maybe I went too far. I did, right here. Here's where we'll leave off. So for the first part, it's just a 1 point, all or nothing. Did you get them right? Okay? The next question is going to be, though, now you got to do some thinking. Now you got to say, okay, which one is going to burn out first? Like they're each going to give their own thinking on this. One of the girls, Abby, thinks that since candle A burns more quickly, it's going to burn out first. The other girl says candle B started much shorter, so it's going to burn out first. So you got to decide who's right. We'll talk about that on Monday. Okay? All right, have a good weekend.
That was the worst part of the math.